Okay, now here we need to get the value of y, right? Now here actually we have no enough other information to mark here. So some questions like this, right? We have to sometime construction. Here we have to do one construction. I will do that way. Now here this is not cyclic quadrilateral first of all, because now you can see this vertex, that means A, B and C, these all three vertices on the circle, right, on the circumference, but this is not on the circumference, so that's why you can't think this as cyclic quadrilateral. But what I will do, to be cyclic quadrilateral, I will make this way construction, right? I will, if I make, right, any point like this, you can join like this, right? You can do this way construction if you need, right? Okay, now you can think if this is cyclic quadrilateral. If I put here name has x, right? Now you can think AXCB is a cyclic quadrilateral, because why? This all vertices on the circumference. So now you can tell 130 plus angle x will be 180, because we know in a cyclic quadrilateral opposite angle are supplementary, or we can call opposite angle 180, add up to 180. So like that, now how we can get angle x? From 180, bring this 130 this side, so it will be 50. Angle x will be, okay, angle x will be 50. Then easily we can find, now this is 50, right? Now you can find this easily, because we learn what the, from the same 2 point or from the same arc, what the angle subtended at center is twice the subtended at x, right? Like the at circumference, actually here at x, but what we learn from same arc, what the subtended angle at center is twice same arc subtended angle at circumference, like this. Now this y will be twice of 50, this one 50, right? This is equal to twice of this, so we can tell y equal 100. After you multiply here 2 into 50, it will be 100, no? So that's why y equal 100.